Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will go for some advanced SQL features in an object-based database that we will use the structured type and the inheritance in SQL. We will first describe the structured type of the data type SQL, and next we will move through examples and go inheritance and different types of inheritance that we can use in SQL as a part of an object-based database. First, we will start with structured type. Before SQL 1999, we cannot have any user-defined data type in SQL. Now onwards, we can create our defined data type. That means the user can define their data type, according to which we can add more than one number of attribute in it and have it as a single compound data type or attribute to be used by the user. So actually it is a complex data type that we will implement using the SQL. Now as we are talking about a complex data type, it can be a compound one, composite, or a multi-valued one. First we are trying to use the structured type on the SQL. We have first created an structured type using the keyword create type with the name in it, and now we are creating the name as two of the attributes, the first name and the last name. But see, when we access name attribute, we will have only the name as a combination of first name and last name. We cannot actually access the first name and last name separately while we have typed it as name. Now we can see that I have created another type address as the street, city and zip code combination. The keywords final and not final is used for subtyping. We will discuss in some later videos. Now we can see that we use the name and address as a data type when we can create a table or an object-based table on an SQL. Let us see and create a table or a relation which will use the name and address as their data type. See, now we have created the name variable with the data type name, the ADR variable with the data type address, and the DOP variable with the system defined data type det. So now when we'll store value for name, it will consist the first name and last name both. Now, other than creating a single variable or attribute, we could have used an user-defined table type too. Say the user-defined table schema that we are mentioning, and we can use a table as a type of that particular table. Let us look at this example. Now, using the keyword create type with a type as the table name or the table schema, name as the name typed attribute, ADR as the address typed attribute, DOB as a date attribute, not final, create table, say there is no semicolon between them, that means it is a single query. Create table person of PT, that means we are creating a table person of type, person type or PT. Now all there we are mentioning is not unnamed row. So we can even name a row using a syntax of a structured type. See, now we can give even the complex data type as a row type naming. That means we are creating a table person row where name is a variable name which will be undefined as a row type, and the row type will consider the first name and the last name characters. And same as the ADR goes with the row type street, city and zip, and along with this DOB as a normal system defined data type det. So here we are creating a row wise, that means for every row it will consider the first name, last name, street, city and zip combination for the name and address. Only with one difference, that while making the table as a person type, the attributes were unnamed, and here the row types are unnamed. That means the attributes were unnamed for the name and it will not give in first name and last name. Now the row will contain not the first name and last name but name. So that is the one difference and the only difference between creating in this way row type or creating a table as another table type. Now, if I want to fetch the last name of a person with which city he is residing on, we can fetch it while having access to the individual attributes in a typed attribute within the dot specification. So the name dot last name will give me the last name of the variable name, and the city of Ekeeda will give me Ekeeda.city. So we can access to every values on that particular attribute of a typed variable with the dot structure. Now we can even have methods in a structured type. That is the main advantage of having the structured type, that it does not only contain the data, but it can also mention the methods to it. That means what are the behaviors associated with the data. Now look at this query. We are creating a type PT as the name as name, the Ekeeda address, and DOB as det, not final. Now look at the second part. I'm using the keyword method to actually using and saying and indicating that a method is being there as a part of the type. So the PT type has got a method. The name is age on det, and it is taking the ONDT on det as a det variable as an input or parameter to it, and it will returns using the keyword returns interval and then the variable name year. That means it will return the year currently of that person's on which the DOB was taken. So the det will be input and returns interval year will be output. So the keyword returns interval, that means for each interval it will return the year of that person. Now see, this is not the definition of the function or method. This is only the prototype or a declaration of the method. Now we will explicitly define the function outside the person type or PT. Now let's look at the first part of the definition, which has got create instance method. What do you mean by instance method? That is particularly available for the table which has been used that party as a person type or the structured type for considering the table. So it is not available for every table. It will be created at that particular instant when the table will be created of PT type. Now that we have instant method, the method name, the variable as the arguments, now returns interval year for the table name PT. So if we are defining your function or method explicitly, then we use the keywords for space the type name along with the method name. Look for the new syntaxes here. I have used begin for the function beginning, return as to return for this function. Now ONDT is the det that will be given to us minus self.dob. What do you mean by self? When we are using the keyword self, that means you're referencing to the first instant or that particular instant or the tuple on that relation. So if it is from the person relation, then the self refers to every instance, that for every instance there will be a particular self.dob. For every tuple there will be self.dob. Self refers to each tuple on the relation. Self.dob means first it will be considered for the first one, second for the second one, and if there is some conditions with the select statement, then it will look for only that tuple which specifies the condition. So in this way, self.dob will be subtracted from ONDT to give the how many years they have lived or what is their age. Now how to use this method? We just simply call this function inside a select statement. So select the last name of the name variable. Along with it, I'm calling the function with the function name followed by the argument that I have to use as a parameter. So the parameter is the current date. So it will be go here and the current date will be subtracted with the self.dob of every person inside the person field. And if I have put any where condition, then only that tuple's DOB will be given to us. Now how to add a value into a structured type which has been used and user defined data type? We just use the row type or is an unnamed type to insert followed by the variable name and the actual values. Let us see an example of a tuple that we are inserting into the person database. Now let's look at this insertion. I have used insert into the table name values. See, I am using the new as a keyword to insert a new structured value. I am not mentioning the attribute name, rather I have to mention the structured type name. Now the values that I want to insert in the exact order, the values or the attribute names that have been mentioned. So for the first name and last name, if I have stored Smith and John, then Smith would have been the first name and John being the last name. Same goes with the address, because see, I have not used ADR but address because it was my structured type name. So now my street name, city name, and followed by the pin code. Now the date variable with this followed by the actual type. See, I have also mentioned the date, which is in a system defined data type, because I am inputting as in a row type, and every data type should be of the row. That means I need to mention the attribute type here, not the attribute name. So that is all for the structured type or the user defined data type that we can use to make a complex data type or attribute, which will be used as a base for the object-based databases. Now we will move to the next part, that is the type inheritance. When we use the type inheritance, it is mostly and absolutely around the object-based databases. Inheritance means specialization. That means a generalized relation is already in there and we are expanding the relation with some attributes added to it. That means, say, if a person is there, we can either introduce the person as a student or an instructor in a university. So the university student or instructor both got the attribute of a person. Say the name and address, that will be go for student as well as for the instructor. But there will be a new feature that can be added as a student and also that can be added as a instructor. So now the student will got inherited all the attributes and methods from the person, and also it will have an instructor that will inherit the attributes and methods of person, addition to some features of it. Now let us see an example of a person and student and instructor as a specialization or inheritance to it. See that I have created a type person with the created type name and adhere to it. That means the name has been created from the typed attribute name, which has got the first name and last name, and now the adhere is the address which has got the street name, city and zip code to it. Now the person is also a type, not a relation, which can be inherited into two of other types. Now when I am creating the type student, I am using create type student under person. What do you mean by under person? That means the person is a part of the student. That means the student is under person's inheritance. That means the person's attribute and method will be get inherited into the student. It can have or have not its own features and methods. So the student has got name, address, degree, department. I do not have to mention degree and department explicitly in person because person name and address will be inherited in student, and I can easily access to student.name, student.address even if they are not mentioned degree and department along with it. Now let us define another type, that is a create instructor or say teacher. Now let's look at this one. The teacher type has got also under person. That means it will also inherit from person, salary as its integer, and also the department as an attribute to it. Now it is of the features or data that we can inherit. Now what happens in case of the method? If we inherit the method, then the same function will be copied to my new inherited type. Now we often want that do not copy the function of that method that we have already in the generalized type. Now when we are specializing some class or a type, then we want some extra function to be performed by that type. So we need to override the method. So we will not use the keyword method, but you will use override method. So the keyword override method will actually let you use that The first use of the method will be in the generalized class, and if you are using the override method, then the new function will be allocated with this method. Now that we have used in our previous definition of a type structure the keywords final and not final, so it is used for subtyping. When you use subtype, that means the subtype of a particular database or a relation. Now the subtyping creates, if it is final, then we are mentioning that the subtype may not be created. And if we are creating not final, that means subtype may be created. We will use final to the relation if we are sure that the relation will not be inherited to other relations. And if it is not final, that means we can use that as an inheritance to other specializations. Now, the SQL supports multiple inheritance too. What do you mean by multiple inheritance? That a single data class or the relation is inherited from two relations or more than two relations. That means if a relation is inherited from two or more relations, they will have all the features of the first relation, the second relation, the third relation, and their method. So let us see how to give the multiple inheritance in SQL. See, I'm using the create type teaching assistant under student comma teacher. So first it will be inherited from student. So the teaching assistant has students features like the degree and department as well as the data of person name and ADR. So when I want to go for a teaching assistant's address, then how can you fetch that? You can use the keyword teaching assistant dot. Now I am moving to the student or teacher, anyone. Student dot ADR if it's been the student, or otherwise teacher dot ADR for a teacher. So we can directly ensure that we will not use the intermediate name on this teaching assistant to ADR. So we can use the multiple inherited or the hierarchical inheritance, that the teaching assistant goes with degree or with the name and ADR, just as it is using the student one or the teacher one. Now the multiple inheritance, there is a problem that is called the diamond problem. So let us define the diamond problem first and then see that how can we solve it using the SQL. The diamond problem coincides that if a further class or the subclass as having a relation on this particular attribute name. Now when it is inherited into two parts and both of it has the same name attribute as their specialized name. Now when there will be a class or a type which is inherited from both the types, so for which data or which attribute that will adhere, the first one or the second one. So that is called the diamond problem. So we can use the particular name on that particular field from the multiple inheritance. Just use the attribute name on that relation. So the relation in brackets we can use the relational attribute. Now suppose we want to create a type with inheritance of a particular attribute from a relation. Say for I want to inherit from the teaching assistant for the department on this teacher or the department on the student. So I will use this as, now say this query that I am creating a teaching assistant under student with department as student type. When we create with clause followed by a relation name, then I am creating an inheritance with the relation name with most specific value. Most specific value means the department now will be considered as student department because it is coming from the student relation, as well as if it is coming from the teacher relation, it will be considered as the TCH department or the teachers department. So now we are dealing with the more specific values other than just saying that which department it is. It is the student department or the teacher department. Now as in teaching assistant, we have the following attributes. The name, address as being a part of the person. For the teachers, it has the salary and the TCH department. For the student one, it has the degree and the student department. So now the relation teaching assistant can refer to any of these attributes with a dot operator being an exclusive part of it. So that is all for the type inheritance in SQL along with the structure type. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.